Right. The unit for mass, when you are measuring your mass, the unit is in kilograms. This one you just have to memorize, okay? Weight. Remember, weight is actually gravitational force. So it's a kind of force, and it is, weight is gravitational force. So since it's a force, the unit of weight will be the unit of force, which is newtons. So A is the answer. Now for question 9. Now question 9 says that there are two forces which plank will turn. So let's take a look at, let's pretend that this is the plank. Okay, so you have a plank here. So let's pretend that we are looking at this. If I have a pivot here, so I'm going to hold it. Now if one force is pulling it up, another force is pulling it up from the other side. So this is clockwise because this is the direction of the clock. This one here is turning it this way. So one clockwise and one anti-clockwise, the plank actually will not turn. For this, okay, so for the other one, let's take a look at the motion again. Again, if for B, right, it will be here. So this force is pulling it, turning this way, that's anti-clockwise. This one is turning it clockwise. So again, if you have an anti-clockwise and a clockwise, it doesn't turn because they cancel out each other. It's the same as when I pull something to the right and left, I pull together, it doesn't move, right? And with the same explanation, this force, you will make it turn clockwise up this way. This one anti-clockwise, so it doesn't turn. But if you look at D carefully, for D, right, this force is turning it anti-clockwise. And this force is also turning it anti-clockwise. So you have two anti-clockwise. So eventually this whole rod is just going to turn anti-clockwise. It's just going to turn anti-clockwise. So it will turn. D, it will turn because both are anti-clockwise. Question 10 is an interesting question. There are a few answers, in fact. This is the picture of the cyclist with the various parts labeled. And they ask, identify one area where the friction occurs. Now, there are a few answers. If your answer is tire, because when the tire is rolling on the floor, there will be friction, then your choice, whether it's advantage or disadvantage. Now, if the tires is experiencing friction with the ground, I would say this is a disadvantage because then the tire marks will be wear out, right? So because friction will wear out the tire fast. But what if you look at the diagram again, other than the tire that is going to experience friction, his hands and his bum, these two parts are going to experience friction too. If there's no friction, this cyclist will keep slipping down from the saddle. If there's no friction, you won't be able to hold on to the handlebar. You know, it will just slip. So there are two other answers. You can say that the saddle is also a place. Wait, is it? Sorry, there are two D's. D, D, L, E. The saddle is also the place where you experience friction. And in this case, it's an advantage because it will prevent the cyclist from slipping off his seat. Handlebar, again, that's why cyclists, they wear gloves to increase the friction so that you can allow the cyclist to grip the bar tightly. Okay? So 3 answers. The answer, this explanation depends on the answer you have here. And the next one, what is the average speed of the cyclist? Please do remember that you have to annotate. The distance is 3.6. The time is in 3.6 kilometers is in minutes. Asking you to calculate the speed in meters per second. So you find that the units are all not consistent. If you are doing this triangle, right? Distance, speed, time. Now, if the distance is in kilometers, the speed will be in kilometers per hour, and this will be in hours. All right? This is one combination of units. Sometimes we may also, with the same formula, but if I want the speed to be meters per second, then this must be in meters and this must be in seconds. You cannot combine the units. All right, so this is one family of units. One family, either you choose this as a set, or this is another family of units. So in this case, which is the family? Well, the question wants you to give answer in meters per second. Okay, they want the answer to be meters per second. So meters per second, which means the distance must be meters, the time must be in seconds. So I will convert 3.6 kilometers to meters, 3,600. I will convert the time of 30 minutes to seconds. And then I'll get my final answer, 2 meters per second. Part C. On another journey, the cyclist changes the speed from 3 to 6 in 60 seconds. What is the acceleration? So again, this is your initial speed. This will be your final speed. This is the time taken. And the acceleration is the unknown. So please do your annotation like that. And I write out the formula. So final minus initial divided by time. And my answer is 0.5.